So we've been asked to find the eccentricity of an ellipse. And they've given us this equation, 9x squared plus 18x plus 25y squared minus 200y plus 184 is equal to 0. We've been asked to find the eccentricity. And I'm going to remind you that the eccentricity of any ellipse is C over A, or I always remembered it's the focal axis over the major axis. Focal axis over the major axis. Okay? So, what do we know? If we can find C and A, we can find the eccentricity. And one last little note here just to help you out. We remember that C squared is equal to A squared minus B squared. So if I know A and B, I can find C. And then we think of the equation of an ellipse, right? What's the equation of an ellipse typically look like? It's going to be something like x minus h quantity squared and y minus k quantity squared over a squared over b squared and equal to 1. And so if I have this equation in this form, I know a and b. I can find C, and then I can find eccentricity. So it's a long way to go to find this. So we've got to put this equation here, which is an expanded form. So it's been multiplied out. It's an expanded form. And we've got to get it in this form right here. Okay, what a lot of people call center form. Okay, why? Because the center is h comma k. All right, so let's take this equation. To do this, we have to complete the square on both variables. We have to complete the square on the x variable and the y variable. So to do that, we're going to write this thing out. We're going to say 9x squared plus 18x. I'll leave a little space very intentionally. 25y squared minus 200y. And then we're going to move this guy, this positive 184, over here and make it negative 184. Okay? So we got this equation. We've got it spaced out a little bit. And remember, to complete the square, this has to be 1. And this has to be 1. So, and we can't divide by 9. We can't divide by 25 because that'll mess the other one up. So we have to factor out. So I'm going to factor out a 9. And leave a little space. And I'm going to factor out a 25. And leave a little space. Okay? And he stays the same. 184. Negative 184. Now, let's actually complete the square as my paper moves on me. How do we complete the square? We're going to take this middle term, divide by 2, and square it. Plus 1. And we come over here and we add 9. And people always look at me funny and say, wait a minute, you added 1. Why'd you add 9? Because 1 times 9 makes 9. Okay? Over here, what do? Divide by 2. We get negative 4. Square it. You square that, you get plus 16. Okay? Alright. Now, what are we going to do? We're not going to add 16. We're going to take 16 times 25 and get plus 400. Okay? So now, factor this. You get 9 times x plus 1 squared. 25 times y minus 4 squared equals, and when you take negative 184 plus 9 plus 400, you're going to get somewhere around 225. Okay? Now your last step, this has to be 1. So we come back in, we'll use a different color so we can see what we did here. We're going to divide that by 225, and if I do that there, I've got to do it here, and I've got to do it here. Okay? Now, the easy one, 225 over 225 is 1. 25 over 225 reduces to 1. 1 over 9. And this guy, 9 over 225, reduces to 1 over 25. And now you've got this equation. So what do you know? That is a squared. That is b squared. 25 and 9. Okay, if you know a squared and b squared, you can finish this problem. So let's take this up here and finish the problem. Matter of fact, I've already got the equation written, right? From earlier. C squared equals a squared minus b squared. So c squared equals 25 minus 9. C squared is 16. C, because this is a distance, an axis length, even though we know it goes to the right and to the left, we're just going to take the positive root here and say that C is 4. Well, eccentricity is C over A, which will be 4 over, well, A squared was 25, right? A squared was 25, so A is going to be 5. And eccentricity is always given as a decimal, so 4/5 is going to be 0.8. The eccentricity of this ellipse is 0.8. And just to make sure that you know what's going on, let me just give you a quick rundown with eccentricity, okay? We hear this word eccentricity, we need to know what it means. So I'm going to give you, first of all, a circle. It has no eccentricity. Now if I take that circle and I stretch it just a little bit in the x direction, that's like an eccentricity of 0.1. Okay? And as this gets more elliptical, it's going to get more eccentric. Okay, so the eccentricity is how elliptical an object is. So this would be like E equals 0.7. Okay, and as it flattens out and becomes more elliptical, this eccentricity gets higher. So that's what we use that E term. So when we look at our answer, E equals 0.8, what do we realize? This is a very, very wide, flat, elliptical looking ellipse. Okay, so anyway, that's the eccentricity of an ellipse. And we're going to do one more, an application here. So let's do the application. Jupiter follows an elliptical orbit with the Sun at one focus. The eccentricity of the ellipse is E equals 0.0489. The maximum distance of Jupiter to the Sun is 507.4 million miles. What is the minimum distance of Jupiter to the Sun? So rule 1 in any class in mathematics is, if possible, draw a picture. It's especially true in things like conic sections, trigonometry, stuff like that. So I've been told that this orbit is elliptical. And you've got two foci. Okay, two foci. And it says the Sun is at one of them. So I'm going to draw. There's the Sun. My best rendition. Okay, there's the Sun. And basically, they've given me some information. They told me the eccentricity is 0.0489. 0.0489, which we know is equal to C over A. Okay? So they've given me that. Now, they've also told me that the maximum distance Jupiter to the Sun is 507.4 million miles. So here's Jupiter. And they're telling me that distance is 507 507.4 million miles. Now, we know somewhere in this ellipse there's the center, okay? And what I want you to pay attention to is from the center to the outside. This distance from here to here is A. It's the semi-major axis. And the distance from here to the foci, either of the foci, but to this particular focus, is C. Okay? So I can write an equation that A plus C is 507.4. Okay, so A plus C is 507.4. And whether you realize it or not, you have just found out how to solve this equation, how to solve this problem, because you have a system of equations. You have an equation here with C and A, and an equation here with C and A. Okay, so we have to solve this equation. Well, I'm going to go ahead and multiply by A up here. So I'm going to take this equation, I'm going to scoot over here, and I'm going to multiply by A and get C is equal to 0.0489A. Okay, so I got that. All right, and then I've got, let's take A plus C equals 507.4. Okay, so I've got these two equations now, where I just rearranged one to get this, and I'm going to substitute this in here. So everywhere I have C, I'm going to put that. So I get A plus 0.0489A equals, right? You see what I'm doing? Substitution. Put that in here. 507.4. Okay? Cool. So now, add these up. I get 1.0489A equals 507.4. And then we're going to divide both sides by, so I'm going to say 507.4 divided by 1.0489. And I get A equals 483.4588, and it just keeps going, and nobody really cares. At some point you've got enough, right? So we now have our semi-major axis. So I'm going to just round this. I'm going to say A equals 483.5. Okay? And that's in millions of miles, because that's what they gave me for the maximum distance. Okay? Maximum distance. So now, with that information, I want to find C. So we know that A plus C is 507.4. Okay? So what do? Rearrange this. C is 507.4 minus A. Put that number in for A. And we get 507.4 minus 483.5. And C equals 23.9 million miles. Okay, cool. Now, we've got A, we've got C. Let's go back to our drawing. Okay, let's go back to our drawing. We'll come back to these numbers in a second. We're going to need them in a second. They asked me, this is the maximum distance from Jupiter to the Sun. Here's Jupiter. They want to know the minimum distance from Jupiter to the Sun? Well, this is A plus C. This distance is going to be A minus C. So what they're asking me to find is A minus C. Oh, well, I know these numbers now. So this is 483.5 minus 23.9. Okay. So we just do the math. Okay. So 483.5 minus 23.9, and I get 459.6 million miles. Okay? And so we use this type of stuff in astronomy and physics, dealing with astrophysics, things like that, dealing with the universe. Okay, so an application of ellipses. All of our planets do in fact have elliptical orbits. They're not perfect circles like we were taught in elementary school. So anyway, it's an application for ellipses. Hopefully it will help you out. If you see a problem like this, the big deal is, do you understand what is A, what is C, and what are they asking for? A plus C, A minus C, right? If you can get the geometry right, the math falls into place pretty well. So if you have questions, let me know.